Welcome, ladies and gentlemen. Today's notes are going to be on balancing equations as well as the law of conservation of mass. We're going to start today's notes by defining the law of conservation of mass, which states that matter cannot be created or destroyed, it can only change form. This means that when we're balancing an equation, the number of the atoms of each element must be the same on each side of the equation as stated by the law of conservation. The number of atoms can't change from the reactant side to the product side. This would mean that the atoms just disappeared, which would break the law of conservation. For example, if I look at our first equation here, H2 plus O2 yields H2O, and I count up the number of atoms of hydrogen and oxygen on the reactant side, 2 hydrogen and 2 oxygen, and I count up the number of atoms on the product side, 2 hydrogen and 1 oxygen, I can see that the oxygen atoms have changed from 2 to 1. This equation is unbalanced and breaks the law of conservation. In order to balance this equation, I will need to change the total number of molecules present on the reactant and product side so that eventually the number of hydrogen and oxygen atoms are equal across both sides. I can do this by changing the coefficient, or the number in front. I cannot add a subscript to the molecule, changing H2O into H2O2, because this would change the molecule into something else. I'm going to start by changing the coefficient on the product side to a 2, changing the number of hydrogen atoms to 4, and the number of oxygen atoms to 2, so it matches the number on the reactant side. The last thing we need to do to balance this equation is to add a coefficient to the hydrogen on the reactant side. If we change it to a 2, we know 2 times 2 is 4, and now we have 4 hydrogens on the reactant side and 4 hydrogens on the product side. We also have 2 oxygens on the reactant side and 2 oxygens on the product side, so this equation is completely balanced. Now we're going to move on to our second example. There is a typo on our page. We're going to change our molecule from C2H6 into C2H4. Normally when balancing an equation, you wouldn't ever change the subscripts because that changes the molecule into something else, but a C2H6 chemical equation is much more difficult to balance. We're going to change this into a friendlier equation, so on your paper right now, change C2H6, change that little 6 to a 4. Next, you're going to want to count up the number of carbon, hydrogen, and oxygen atoms on the reactant and product side. On our reactant side on the left, we see we have 2 carbons, 4 hydrogens, and 2 oxygens. And on our product side, we have 1 carbon, 2 hydrogen, and 3 oxygens. 2 of our oxygens are in the CO2 molecule, 1 of our oxygens is in the H2O molecule. We're going to start from the top of our element list here, so we're going to start with carbon and try and balance our equation. We have 2 carbons on the left-hand side on our reactants, and I have 1 carbon on the product side. We're going to find the least common multiple of carbon between 1 and 2. That's going to be 2. I'm going to correct this on my chemical equation by putting a 2 as the coefficient, or the number in front of the CO2 molecule. By putting a 2 in front of the CO2 molecule, I've changed the carbons to 2, and I've also changed the total number of oxygens on the product side. I now have 4 oxygens in carbon dioxide and 1 oxygen still in water, for a total number of 5 oxygens. Now that the carbons are balanced, I have 2 carbons on the reactant side, 2 carbons on the product side. I want to take a look at the hydrogens. I have 4 hydrogens on the reactant side and only 2 listed on the product side. I'm going to look for the least common multiple of hydrogen. The least common multiple of 2 and 4 is going to be 4, the smallest number they both multiply into. I can change the hydrogen on the product side into a 4 by adding 2 as our coefficient in front of water. 2 times 2 is 4, so I'm going to change my hydrogens on my notes down below to 4, but I've once again changed the number of total oxygen atoms. Now I have 2 oxygen atoms in water plus our 4 oxygen atoms in carbon dioxide for a grand total of 6 oxygen atoms on the product side. I've almost finished balancing this equation. The number of carbon atoms on the reactant and product side are the same, it's 2. The number of hydrogen atoms on the reactant and product side is also the same, we have 4. But the number of oxygen atoms are still unbalanced. So I need to find the least common multiple of 2 and 6 for oxygen. That's going to be 6. And I'm going to need to change the number of oxygen atoms on the reactant side. I can convert 2 oxygen atoms on the reactant side to 6 by adding a 3 as our coefficient in front of O2. This changed the total number of oxygens on the reactants to 6, the total number of oxygen atoms on the product side also to 6. This equation is completely balanced. Last thing we need to do for our notes is define an exothermic versus an endothermic reaction. An exothermic reaction releases energy, usually in the form of heat. Energy is a product of the reaction, and the reaction will feel warmer once it is complete. I like to think of exothermic as the heat exiting the reaction, which is why it feels hot. An endothermic reaction is going to absorb energy. It feels colder when the reaction is complete. The energy is a reactant, so it's used, which is why it feels cold.